couple of physics problems here for you. I'm going to do 1 through 4 in this video, and then I'll put 5 through 7 in another one. Elevator is moving up at a constant velocity. Constant velocity. So I'm going to look for keywords like this. Constant velocity means forces are balanced. Balanced. As illustrated in the diagram below, passenger has a mass of 85 kilograms. Construct a force diagram for the passenger, not for the elevator, for the passenger. What are the forces acting on the passenger? Well, there's gravity, of course, because gravity doesn't care what's going on. That's on the passenger from the entire Earth, and that's going to be their mass times 10. And they're going at a constant velocity, so forces are balanced. Now, what is this force here? Is it from the cable? No, the cable's not attached to the person. The thing that's pushing up on the person is the floor of the elevator. Well, that's just a support force. Support on the person from the floor of the elevator, and that's going to be 850 newtons as well. Calculate the force the floor exerts on the passenger. Did it. All right. Elevator now accelerates upward. It's accelerating upward. The acceleration is not zero. So that means the forces are not balanced. And since it's accelerating upward, that means up is winning. Construct a force diagram for the passenger. Well, you know what? Here's the thing about gravity, in case you haven't been picking up on this. Gravity don't care. It's still 850 newtons. Doesn't matter whether you're in an elevator or sitting at a desk at school, lying in your bed, kicking back on a lawn chair on the beach. I guess that's a beach chair if it's on the beach. The lawn chair on your lawn. Whatever, force of gravity on you is the same. What about the upward force, the support force? Well, the support force must be winning, so it must be bigger. Maybe you've had this feeling before. If you've ever been in an elevator, I bet you have. Normal force on the person from the floor. That right when not when the elevator is going up, but right at the very beginning when you're on the first floor and it starts to go up, you feel a tiny bit heavier just for a second. Now, you're not actually heavier. You still have 850 newtons of gravity, well, if you're this person, acting on you. But the floor pushes up, and the floor has to push up a little harder to get that acceleration to happen. And that makes you feel heavier. Write an equation for the vertical forces on the passenger. So this is the equation. Unbalanced force, we always start with this, is equal to winner minus loser. That is the equation that we're looking for, right there. Really need you to get the hang of writing those equations. It's just the equation that describes who's winning and who's losing. The unbalanced force is equal to that minus that. And then calculate the force the floor exerts on the passenger. Well, that's the normal force, so unbalanced force.
If there's anyone left that would like to come to the auditorium to have your picture taken, feel free to do so at this time. This is the last call to have your picture taken in the auditorium for today.
So I'm going to put in the stuff that I know. I'm taking this equation right here. I'm turning unbalanced force into mass times acceleration. The normal force, that's what I'm trying to figure out here. Force the floor exerts on the passenger, that is the normal force, minus force of gravity. And now I know the mass of the person is 85, the acceleration is 2. I was given that in the problem, minus 850. And math happens, and you should get let's see. we get 1,020? So that person feels a little bit heavier. How heavy do they usually feel? Well, they usually feel, if there's not any kind of crazy acceleration going on, like if they're just standing on a floor, that's how much normal force they usually feel. And now they're feeling this much. That makes them feel heavier. All right. Upon reaching the top of the building, the elevator accelerates downward. Now, if you think that means they're going down, you are wrong. They're going up, but they're accelerating this way. That means they're slowing down, and that happens in an elevator. You get up to the top, the elevator slows down. So that means they're going up, but this is the thing that matters for who's winning and who's losing. So if it's accelerating downwards, that means down is the winning direction. So force diagram, you know how much gravity there is? Yeah, you do. 850, because gravity doesn't care. And then if down is the winning direction, that means that the support force has to back off. And you've probably had this feeling too, where the elevator comes up to the top and you feel just a little bit lighter. I don't know what that's equal to yet, so let's keep going, and I think we'll be able to figure it out. Write an equation for the vertical forces on the passenger. Same thing, this is not with numbers plugged in yet. This is the unbalanced force is equal to winner. This time gravity's winning, because down is the winning direction, minus the support force. And now calculate the force the floor exerts on the passenger. So the unbalanced force is mass times acceleration. Gravity, 850, minus that. Mass, I think the acceleration this time is 3. Algebra, add that over here, subtract that. So 850 minus 3 times 85. 595 newtons. While descending in the elevator, the cable suddenly breaks. How big is the force on the passenger by the floor? Explain your answer. There's different ways you go about this, but when if the cable breaks, the person is going to be in free fall, right? And we know that in free fall, this is back from chapter 4, unit 4, that passengers in free fall, that means they have an acceleration of 10 meters per second squared in the down direction. So down is definitely winning. So what are the forces on them? Well, there's this force of gravity. You know how much there is? 850. That's right. So the question is there any support force or not? So here we could say, like maybe I'll just make a little dotted line here and say it's a question mark. Is there a support force? I don't know. If there was one, definitely we're accelerating downward, so this is winning. So unbalanced force is equal to gravity is winning minus the support force. Unbalanced force is mass times acceleration, and there's 850 newtons of gravity minus the normal force. Mass of the person is 85 times 10 is 850. And the only way you can get 850 to be equal to 850 minus something is if that something is 0. So there is no support force. And if that seems weird to you, well, I wouldn't try this if I were you. But it's like that there's an amusement park ride called the Drop Zone or something like that, one of these free fall things where you fall like this, and it makes you feel kind of weightless as you're going down. So also, fun thing to check out, if you've ever seen these test flights that they do for astronauts where they fly planes in these parabolic arcs just like something would fly through the air if it had been thrown like really, really fast. And while the plane is following that trajectory, the people on the plane float around inside the plane because there's no support force on them. So this is a real thing. This is for real. This isn't just like weird, like, oh, physics problem says this, but that's a bunch of crap because it's not really true. This really is true. This is the way that things happen. If you've never seen like what it looks like on the inside of one of those planes when they're doing that, it's pretty crazy because all the people are sitting there and then they start floating around as the plane starts to follow that parabolic arc. So check that out. And I'll put up another video for the rest of these pretty soon.